All right, guys, so we're going to go ahead and start with section 10.3. And as you're going to see throughout this section of notes, we have 4 really dense theorems, but then the rest of it's just application of it. All right, so we're going to have to just get through this vocab and then apply it afterwards, okay? So we're going to start with theorem 10.2, and as you can see, I already have them written out, so whenever you're watching this, just go ahead and pause so that you can write them down with me. But theorem 10.2 starts off with, in the same circle or in congruent circles. All right, that's a really important phrase because what we're talking about then is we're talking about lengths and measures of arcs. All right, so if that's the case, then we know that the circles have to be either the same circle or congruent circles so that we have congruent arcs. Okay, but 2 minor arcs are congruent if and only if their corresponding chords are congruent. Okay. So I'm going to draw a picture of this. So I'm just going to draw it in the same circle. All right, so I'm going to start with the circle. And I'm going to put my center in that circle. Oh, that's a pretty big center. Okay, so it says 2 minor arcs are congruent if and only if their corresponding chords are congruent. So what I'm going to do next is I'm now going to draw in 2 chords. All right, so I'm going to go ahead and draw in a chord up here. And then a chord down here. And then let's go ahead and actually name those chords. All right, so let's call this chord AB. And then this chord CD. And what we know is that AB and CD are congruent. So we know AB and CD are congruent. So what this theorem is allowing us to then conclude is that if we know that those chords are congruent, then we know that these arcs are congruent. So that I could say that arc AB is congruent to arc CD. And so we could actually switch that around too. Let's say instead I started off knowing that the arcs are congruent, then I could conclude that the chords are congruent. All right, so you can go both ways on that. So one more time, all right, in the same circle or in congruent circles, 2 minor arcs are congruent if and only if their corresponding chords are congruent. All right, so this next theorem is like super massive, and we use it quite a bit. So in theorem 10.3, it says if a diameter or a radius of a circle is perpendicular to a chord, then it bisects the chord and its arc. Okay, so there's a lot of stuff in here. So we're going to go ahead and draw our circle again. And we're going to put in our center. Okay, so what we're going to now do is we're going to draw in a chord. And I'm going to draw it just so that it's going straight down here. So there's our chord. And let's go ahead and put our 2 endpoints there. And let's call them E and F. And so what this theorem is saying is I'm going to now draw in a diameter or radius that's perpendicular to that chord. All right, so I'm going to go ahead, I'm just going to draw a radius. So I'm going to draw this radius that's perpendicular to this chord. And let's call that radius, let's actually name the circle K and then J. And then let's have this intersection point be H. So there's a lot of stuff in there. But what this theorem is saying is that it has to be perpendicular. All right, so this is what the hypothesis of our theorem is saying. All right, if we have a diameter or radius that is perpendicular to a chord. So then our conclusions for this then, all right, it says that it bisects the chord. So my conclusion would be that H is the midpoint of that chord, which means that EH is congruent to HF. But then it also says that it bisects its arc, so then I know that EJ is congruent to JF. So I can pull two sets of information from that theorem, that it bisects the chord and it bisects the arc. So the next one is actually it's a converse of 10.3. So this one is saying, though, the perpendicular bisector of a chord is a diameter or a radius of a chord. All right. So if we would just go ahead and draw again our circle. Okay. Put in our center. And what I'm going to draw is, again, I'm going to draw a chord. All right. And I'm going to draw it. Let's draw it up here. Let's change our perspective a little bit. And let's name those L and K. And so what we want to do is we want to focus on this chord, and we want to draw the perpendicular bisector of that chord. All right. So if I would draw that perpendicular bisector of that chord, and I'm going to draw it so that it's all the way through, what you're going to notice, so let's actually notate first, all right, that it's a perpendicular bisector. All right, so I'm going to make it perpendicular. I'm going to make it a bisector. So what you're going to notice, though, is that segment would pass through the center of the circle. So that means that this segment right here has to be a diameter. So let's just go ahead and write this MN. So then we know that MN has to be the diameter. And then if MN is the diameter and we name the center of that J, then MJ has to be the radius. All right, so our last theorem is theorem 10.5. And this one says, in the same circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. Okay. So our last theorem here, let's go ahead and explain what this means. All right, so I'm going to draw my circle again and put in your center. So what we're going to do is we're going to draw two chords, and we're going to appear that they are congruent. Okay. So let's name that first chord WX, and then let's name the bottom chord YZ. So what we don't know yet is that they're congruent, all right? But what this theorem is saying is that those two chords have to be equidistant from the center, right? Which means that if I'm going to draw the distance from a point to a segment, we've talked about this before, where it has to be the perpendicular segment that connects them. So I'm going to draw in this perpendicular segment to WX, and then I'm going to draw in the perpendicular segment to YZ. And if these two segments right here are congruent, so if they are equidistant from that center point, then our conclusion then is that this WX has to be congruent to YZ. All right, so WX is congruent to YZ. That's our conclusion. And then if we know that WX and YZ are congruent, then we also know that arc WX has to be congruent to arc YZ. But it has to be equidistant. It has to be the perpendicular distance from the center. So I'm going to pause here. And after this, we're now going to apply